5a, we're learning about, this is where we're starting 5a. In 5a, we're talking about the two ways in which we can measure an angle. So you don't have your notes book, maybe just write this down on some paper that you do have. Not that you need to write all this down, let's just do the examples together. Okay? Just do the examples together. So, the two ways are in degrees. Now we're very familiar with degrees. And degrees, the example I give is it's like if you have a pizza and you cut it into 360 pieces. Alright, so it's in quarters, and then you cut each quarter into 90 pieces. Alright, so you've got lots of thin slivers. Each piece is 1 degree. Now, can anyone tell me why do we use 360 degrees? Why not 1,000? It could be 1,000, it's an arbitrary number. It could be any number we make up. Why do we use 360? This is just a fun side note. Harry?
Well, I guess 360 degrees makes a full rotation from one point back to that one point.
Yes, it does.
1 degree plus 1 degree plus 1 degree plus 1 degree.
Yeah, that's right. Why don't we set it as 1,000 instead of 360? Because we could easily divide a pizza up into 1,000 pieces or 100 pieces. Why have we used 360? It's a tricky question. The answer is it actually comes from sort of an ancient counting system. The Babylonians had a base 6 counting system. And 360 degrees, it turns out, is divisible by every number from 1 to 10 except what? 7. Very good. It's divisible by 1, 2, 3, 4, 5, 6, 8, 9, 10. Every number from 1 to 10 except 7. So it's quite powerful in that you can provide lots of divisions. That's why we use 360. Okay, it divides evenly very well. And it's just something that's stuck. And it's an arbitrary number, right? That's what degrees means. Let's not spend too long on it. Next, let's move on to radians. Now, radians is a unique measure of an angle, and this is non-arbitrary because it's dependent upon the radius of a circle. So if I have a circle here, all right, and the radius is equal to r, okay, r for the radius, then 1 radian, the angle of 1 radian is going to be the angle I have when I travel 1 length of r around the circle. Okay, so it's when the distance from here to here is equal to the radius of the circle. That's 1 radian. If I were to travel half the distance, okay, that would be half a radian. If I travel twice the distance, the angle is 2 radians. So in radians, it's a measure of how many radii, how many radiuses have I moved around the outside of the circle. That's what it means, okay? Let's get into the calculations. They're both very easy. Here we have a formula for you. If we're going from degrees to radians, we multiply by pi on 180. And if we're going from radians to degrees, we multiply by 180 on pi. So this is one where you're literally just using your calculator. We've got convert the following to the opposite form of angle. We're going from 75 degrees to radians. So we're going to multiply it by pi on 180. So we just put into our calculator, you can do it in your head if you want to, 75 times pi on 180. Okay, put that in. Now, it's going to pop up like this. And if we can leave our answer in terms of pi, then we should. Okay, so your calculator, if you've got the graphics calculator, that should be the default setting. It should leave the answer as a fraction. Alright, 5 on 12 pi. And of course, the way you can change it to be in as a decimal by pressing the F to D button or the S to D button. That's just above the 8, S arrow D, F arrow D. That changes it to a decimal, okay? So this is exact. It includes every possible decimal place. Remember, pi is a transcendental number. It's also what we call a irrational number, and that means it has an infinite number of decimal places. It keeps going on forever. 3.1514159, and it just keeps going. Anyway, so we have 5 on 12 times pi, and this evaluates to 1.308. You can see the calculator rounds it after about 10 decimal places. All right. I'm saying when you answer these, leave them in terms of pi. The only reason I'm providing this explanation is to show you that here it's expressed as a fraction and we can convert it. So I'm making the point they go vice versa. All right, next one, 31 degrees. So we go 31 times pi on 180. All right, we've got 31 on 180 pi. Okay, and then maybe one more comment I'll make is 31 on 180 times pi is the same as 31 pi on 180, isn't it? All right. If you've got a fraction times a number, remember the number by itself is on top of 1, and when you're multiplying fractions, it's the top times the top and the bottom times the bottom. So you can express it like this or like this. It doesn't matter. They're both doing the same thing. Okay, 145 degrees, 145 times pi on 180. 3 on 4, 29 on 36 pi. Okay, so they're all in degrees, and if we're converting to the opposite form, we're starting from degrees and going to radians. Very good. Let's go from radians to degrees. Now we're going to multiply it by 180 on top of pi. So our first one here, 3 pi on 2, and we're going to multiply that by 180 on top of pi. So let's just show you what's going on here, right? If I'm multiplying these fractions, I've got 3 pi on 2 times 180 on pi. I've got pi at the top and pi at the bottom, so that's going to cancel. And I have 3 times 180, so that's 540, divided by 2, 270. Alright, so you can calculate it manually, you can just put it in your calculator. It's going to pop out with 270 degrees. Now, I'll just jump back to the first three, just as a technicality. So for degrees, we use the subscript little circle, right? That's the symbol for degrees. And of course, intuitively, makes so much sense, for radians, we use C. Yeah, I don't know, it's something that's stuck with mathematics. So C, uppercase C, is superscript C is the symbol for radians. Okay, pi on 6, multiply it by 180 on pi, get 30 degrees. And then we've got 2C, so that's 2 times 180 divided by pi. It's 360 divided by pi. And you could leave it as 360 on pi. But if you put it in, we'll get 114.5. Alright, here's a good time to talk about rounding again. Always write the first 4 numbers, round the last one. 5 rounds up, which means this rounds up to 115 degrees. Okay, so what's the takeaway? All we're doing in exercise 5A is converting from degrees to radians. Here's the formula. We multiply by pi on 180 to get to radians. We multiply by 180 on pi to get to degrees. So if it's in degrees, you convert it to radians. If it's in radians, you convert it to degrees. Use your calculator. Any questions? Alright, so we won't spend long on 5A. I'll just scroll up quickly to have a look at what questions I've selected from the textbook. So exercise 5A, I've written quite a few there. Let's just start with the first 2. Okay, let's just start with the first 2 out of 6. Alright, does anyone need anything from the notes book up on the board?